You're standing in a river, water up to your knees. You glance down, and there it is, a small, shiny stone tumbling toward you along the riverbed. A diamond. You can hardly believe your eyes. But here's the thing, that moment doesn't exist. A rough diamond is heavier than any common stone its size, so when a current rolls gravel downstream, the light stuff moves first. The diamond doesn't roll with it. It sinks. It buries itself under the gravel and stays put while everything else washes away. That's the first secret of diamond hunting. The current is not your ally. It's the thing that hides the prize. The diamond is the last stone to move and the first to be buried. So the real search isn't about spotting a gem sparkling in the water. It's about reading the river, finding the places where heavy minerals get trapped, the spots where a diamond too heavy to roll has been sitting for years, maybe thousands of years, waiting. But here's the question that changes everything. Where do those traps actually form? And when you find one, what does the prize even look like? Alluvial deposits are where heavy minerals actually collect. These are the clumps of gravel that form in rivers over millions of years. Gold, titanium, diamonds, they all end up here. Not every river has them, but every river diamond you've ever heard of came from one of these deposits. Now, these gravel beds exist in two very different states. You have flowing rivers with active gravel shifting in the current. Then you have dry rivers, ancient beds that dried up thousands of years ago. In those dry beds, you'll spot a small pile of gravel and silt sitting there. All you have to do is dig a little, remove the gravel, add some water, and use the same technique I'll show you shortly. Here's the buried logic that makes this all work. Because diamonds are the heaviest thing in that pile, they sink. They work their way down to the bottom of the gravel, while lighter stones wash over them. The gravel trap is a density filter, not a random pile of rocks. The heavies concentrate at the base, and sieving from the top reveals them last. One more thing before you start digging. Don't expect to find a perfect crystal. Diamonds found in rivers are rarely the beautiful hexagonal shapes you see in underground mines. They're irregular, semi-polished. They have prominent edges, worn down from violent collisions with other stones. Even the hardest mineral on Earth gets scuffed up when it's tumbled against gravel for thousands of years. So when you're looking, don't hold out for something that belongs in a jewelry store. You're looking for something that looks like it's been through a war. Which brings us to the real question, how do you actually spot one of these battered stones among all the other gravel? The first thing you'll notice is the metallic luster. It's unique to diamonds. Put a rough diamond next to a piece of quartz, and the difference jumps out at you. Quartz is transparent, glassy, almost watery. A diamond is opaque. Its surface reflects light like a polished piece of iron, not like a stone at all. Look closely, and it almost seems oily, greasy, even when it's completely dry. That's the shortcut. If a stone in your sieve looks like a chunk of metal instead of a crystal, it deserves a second look. That visual signature separates a real diamond from every common river stone you'll come across. Once you've seen that metallic glow side by side with the glassy shine of quartz, you won't confuse them again. But that same metallic look shows up in other heavy minerals hiding in the same gravel. So how do you tell them apart? Diamonds are rare. That's the whole problem. You could sift gravel for weeks and never see one. But garnet, ilmenite, and chromite, those are different. They're far more common, and they form under the same deep mantle conditions that create diamonds. So when you find them in a river, it means the same geological plumbing that pushed diamonds to the surface was probably working in your area too. That's why prospectors call them indicator minerals. They're not the prize. They're the proof that the prize might be nearby. Take pyrope garnet, for instance. It's the most common type you'll find in rivers, and it's usually reddish, sometimes dark, sometimes with a brownish tint. It often shows up in round or cubic shapes with several sides, and it's heavy. In fact, it can be so polished by the water that it almost looks like a diamond itself. Some cut garnets are worth real money, but that's not what you're looking for. You're looking for the signal. Then there's ilmenite. This one is black with a metallic sheen, and it's triangular in shape with a number of facets. It looks like a piece of iron. It's very heavy, and it has a hardness of about 6 on the Mohs scale. Here's the trap at first glance. Ilmenite can be mistaken for carbonado, the darker variety of diamond that people call black diamond. But there's an easy way to tell them apart. Take a quartz. Crystal quartz has a hardness of 7 and scratch the stone with it. If the stone gets scratched, its hardness is below 7 and it's not a diamond. Ilmenite will fail that test every time. The last of the trio is chromite. It's another iron oxide, this one containing chromium along with other minerals. It has a dark metallic appearance, but its formation is irregular, more rustic than ilmenite. And it's heavy, almost like pure iron ore, much heavier than other stones of similar size. It regularly resembles a piece of lead. Finding chromite in a river is a strong sign that diamonds may be present. It can also point to sapphires and rubies, so when you're sorting through gravel, keep an eye out for these 3. They're your clue that you're in the right place. But finding them is one thing. Getting what you're after out of the river is another, and that takes a different set of tools. Here's the thing about size. And I want you to hear this before we even touch a sieve. Most river diamonds are tiny. We're talking smaller than a grain of rice. If you're scanning for a big, shiny rock, you're going to walk right past the real prize. A diamond over a gram, just 1 gram, is already a big find. So calibrate your eyes for small metallic flecks, not large crystals. Now, to actually get those heavy minerals out of the river, you need sieves. Start with 3 of them, each with a different mesh size, coarse on top, medium in the middle, fine on the bottom. The finest one is where the diamonds usually end up, so treat it with respect. You'll also want a shovel to load the gravel and a prospector's paddle as a handy alternative. Here's the technique. Load some river gravel into the top sieve, then make circular movements with the whole stack. This is where the physics we talked about pays off. The diamond is heavier than everything else, so it sinks. It drives itself down through the lighter material to the bottom center of the pile. Meanwhile, the circular motion migrates the lighter stones outward and up where they wash away with the water. You're left with the heavies concentrated right in the middle. If you're using a prospector's paddle instead, same idea. You gradually push the lighter material out with the water, leaving only the heavies in the center. It takes a little practice to get the motion right, but within a few minutes, it becomes natural. You'll find your rhythm. Once you've sieved through everything, you're not done. You have to spread out all that remaining heavy concentrate on a flat surface. And look, really look. This is where you remember that metallic luster, that oily, polished iron shine that separates a diamond from every glassy river stone. Your eyes are now calibrated for the small stuff. So scan slowly and don't let a transparent pebble fool you. The technique is one thing, but the gravel is full of lookalikes. So once you have your concentrate, what are the specific crystal shapes that actually confirm you're holding a diamond? The octahedron is the shape most people picture when they think of a diamond. 8 sides, 2 pyramids joined at the base. You've seen this form before. It's the same geometry as the Louvre pyramid, the one that reflects in the water to create a perfect 8-sided figure. These are the most common natural diamond shapes, and you'll find them in places like Colorado and Arkansas. But not every diamond follows that classic mold. Some are almost spherical round, but with a surface that's completely irregular. No defined faces at all. Those are rare, and collectors prize them for exactly that reason. Then there's the dodecahedron, with 12 sides made of 12 pentagons. Plato linked this shape to the universe itself. It can appear flat or rounded, with anywhere from 12 to 24 faces. If you're hunting in Africa, this is the one you're most likely to see. Now, the ones that really grab attention are the cubes, perfect dice, often in yellow, red, green, orange, or brown, with a more opaque look. They're uncommon and highly sought after. And there are triangular diamonds. 2, an almost perfect triangle, with smaller triangular textures across the surface. You'll find those in various parts of the world, but they're less common than the others. Here's the thing though, most rough diamonds you'll actually find in a river don't have any of these defined shapes. They're irregular. But they carry a secret on their surface, small triangles, a typical sign of natural origin. And when a diamond fractures, it doesn't break smooth like quartz. The surface looks like brushed steel with striations running in one direction. That's your clue. So when you're scanning your concentrate, don't look for a perfect crystal. Look for that metallic sheen and those surface details. They're what separate a real diamond from a clever piece of quartz. But what if you're still not sure? There's a simple test that settles it, and it costs less than $1. So you've got a stone that looks the part. Maybe it's got that metallic glow. Maybe the shape is right. But there's still that little voice. What if it's just a clever piece of broken quartz? For less than 50 cents, you can settle it for good. Head to any hardware or paint store and grab the coarsest sandpaper you can find. It's usually dark, almost black. That dark grid is a material called carborundum, basically industrial ruby. On the Mohs scale, it sits at a hardness of 9. That's hard enough to scratch almost anything you'll find in a river. Everything, that is, except a diamond, which sits at a perfect 10. Now, for the test. Take your suspect stone and rub it firmly against the sandpaper. Be patient. You can press hard, and even pour a little water on the paper to make the rubbing easier. Here's what you're watching for. 2 outcomes, and they're completely different. If the sandpaper starts to wear down, but the stone stays perfectly smooth and intact, congratulations, that's your verdict. You've got a real diamond in your hand. But if you see white powder forming as you rub, and the stone's surface starts to get scratched and worn away, that's the other outcome. Your stone just failed the test. Its hardness is below 9, which means it's not a diamond. It's probably quartz or some other shiny imposter. That's the trap, by the way. A broken piece of quartz can have an intense, glassy shine that fools a lot of beginners. But glassy is the key word, it's not metallic. And the moment you put it to the sandpaper, it loses. So now you have a way to know for sure. But that raises another question. Even with the right test, how likely are you to actually find something worth testing in the first place? Here's the thing. Even the most experienced prospectors go months, sometimes years, without finding a single diamond. That's the honest truth. But it's not impossible. Luck plays a part, sure. But luck without knowledge is just walking around picking up rocks. Knowledge is what turns a lucky moment into an actual discovery. And here's something most people don't realize. Not every diamond you find is going to be the clear, sparkling gem you picture. Some are darker. Some are full of inclusions, tiny flaws trapped inside. Those are industrial diamonds. Lower value, but still real diamonds. Still proof that you're standing in the right place. So if you find one of those, don't be disappointed. Rejoice. Because that dark, imperfect stone is a geological green light. It tells you the ground beneath your feet has produced diamonds before. And if it's happened once, it can happen again. That's not a failure, that's a signal to keep looking. That's what separates the people who find diamonds from the people who walk right past them. Attention to detail, knowing what the metallic luster looks like, recognizing the indicator minerals, understanding the crystal shapes. That knowledge multiplies your chances in ways pure luck never could. Every stone you pick up and examine is practice. Every wrong guess teaches you something. The people who succeed at this aren't the luckiest, they're the most prepared. And now, with what you know, you're one of them. But knowing the pieces is one thing. Putting them all together into a single, reliable search plan, that's where the real hunt begins. Every diamond that has ever been found started in one place. A rock called kimberlite. Kimberlite is ancient. It formed deep in the Earth's mantle under pressure and heat so intense that carbon crystallized into diamonds. Then, in violent volcanic eruptions, it was blasted up toward the surface. And because kimberlite and diamonds come from the same part of the mantle, that eruption often carried the diamonds up with it. As the rock cooled, it hardened, locking the diamonds inside. So, the logic runs one way. Not every kimberlite contains diamonds, but every diamond came from a kimberlite. That makes kimberlite the first place to look. It's a dense, dark gray stone, and it's filled with inclusions. One of those inclusions is worth your attention, olivine. Small green crystals that also form deep in the earth and ride up with the kimberlite. If you can spot those green crystals, you're looking at the right kind of rock. Now, rivers are the second best place to search. They do the hard work for you, eroding kimberlite over time and carrying the diamonds downstream, but you won't find them floating in the current. The same 3-sieve setup works here, and the same circular motion. The heavies sink to the center bottom of the pile. That's where the diamonds end up. Then there's the third option, alluvial deposits. These are ancient riverbeds, buried for thousands or even millions of years, packed with gravel that has settled over time. The gravel looks just like what you'd find at the bottom of a working river, and it can hold the same prizes, diamonds, even gold. When you explore one of these, you'll want water on hand to get a clear look at what you've uncovered, but the rules stay the same. Same indicators, same metallic luster. One more signal is worth mentioning. Flates. It's a type of magnesium-rich mica that shows up as small golden or greenish blades scattered across the ground. If you see those flakes in an area, that's a strong sign. The ground beneath you may hold diamonds. You will never see a diamond rolling toward you in the water. Its weight guarantees that. The current carries everything lighter away, and the diamond sinks buried in the gravel. That weight is not the enemy. It is the key. Weight dictates where the gem settles. It tells you how to sieve, what to look for, how to read the river. Master the weight, and you master the entire search. The heavy stone is the one that stays. The heavy stone is the one you find. This hobby connects you with nature, and it has the potential to bring real income. Every stone you analyze is a lesson. The knowledge you now hold is the real treasure. The diamond is simply the reward for patience. If you want more of this kind of hunting, subscribe. There are more discoveries waiting. And tell me, what's the one place you'd start looking first?